Hi everyone, and welcome to part 3 of the Introduction to Technical Drawing. In this session, we'll explore on technical drawing instruments and software. At the end of this part, students should be able to identify and use appropriate manual drawing instruments and CAD software tools for creating accurate technical drawings. Alright everyone, let's take a short trip back in time, before computers and CAD software took over. Back then, all technical drawings were done by hand, using a set of specialized tools on large drawing boards. These manual drawing tools, or what we call traditional instruments, were essential for engineers, architects, and designers to draft precise lines and shapes. Let's go through some of these classic tools. First up, we have the French curve. This is a really neat tool made from plastic or wood, and it's used to draw smooth, flowing curves that you can't get from a compass or freehand. If you're sketching something like the curve of a car hood or the blade of a fan, the French curve gives you that elegant, consistent shape. Next is the protractor. You've probably used one before in school. It's that semicircular tool used for measuring and drawing angles, super helpful when working on components that need exact angular dimensions, like gears or connectors. Then we have the T-square and set squares. The T-square helps you draw perfectly horizontal lines, while the set squares, usually 30, 60 or 45-degree triangles, help you draw vertical and angled lines. These are critical when you need to construct clean, accurate geometry in your technical drawing. Of course, we can't forget the basics: mechanical pencils, erasers, and drawing sheets. Mechanical pencils are preferred because they provide a consistent line thickness, and erasers, well, they're the lifesavers when it comes to fixing tiny mistakes. The drawing sheets used were typically standardized, like A3 or A1 sizes, and placed on a drafting board for support. Even though we mostly use CAD today, these manual tools still play an important role in learning the fundamentals of drawing. They teach patience, attention to detail, and spatial awareness, skills that are just as important in the digital world. So, while these tools might seem old school, they laid the foundation for everything we do in modern design today. Let's move into the digital age, where computer-aided design, or CAD, has completely transformed how we create technical drawings. CAD tools are software platforms used to produce both 2D and 3D technical drawings. Instead of drawing by hand, we now use computers to design parts, products, and entire assemblies with a much higher level of precision and efficiency. CAD is a general term that refers to any software used for creating technical drawings, blueprints, models, and layouts. These tools are now industry standard across engineering, architecture, manufacturing, and especially in product design. One of the most popular CAD tools used in mechanical and polymer product design is SolidWorks. This software uses something called parametric modeling, which means that the shapes and dimensions of your design are linked, so when you change one part of the design, the rest updates automatically. It's great for designing complex parts like plastic casings, bottle caps, or mechanical assemblies, and is widely used in polymer and manufacturing industries. Next, we have AutoCAD, which is one of the earliest and most well-known CAD platforms. It's still widely used today, especially for 2D drafting and layout work. Think of technical floor plans, product schematics, or piping layouts. It also has 3D capabilities, but it's often favored for its simplicity in 2D work. Other powerful CAD platforms include Fusion 360, which is cloud-based and great for collaborative design and simulations, CATIA, which is often used in aerospace and automotive design, Inventor by Autodesk, which is similar to SolidWorks, and Rhino, which is preferred for its ability to handle organic, free-form shapes, making it popular in product design and prototyping. These digital tools offer massive advantages: easy editing, precision control, 3D visualization, fast prototyping, and better collaboration. In fact, most companies today would find it almost impossible to work efficiently without CAD software in their design and production workflow. For the conclusion, in this chapter, we've explored the foundations of what technical drawing really is, not just lines on paper, but a universal language used by engineers, designers, and technologists to communicate ideas clearly and precisely. We saw how technical drawing differs from artistic drawing. One is open to interpretation, while the other is all about accuracy and consistency. We also discussed the objectives of technical drawing, including its roles in communication, documentation, process planning, quality control, and innovation. These aren't just theoretical concepts, they're vital in real-world design and manufacturing environments, especially when you're working with polymer products or collaborating across teams and departments. Then we moved into how technical drawings fit into the product design and development process, from initial research and concept design to prototyping and production. You saw how drawings support each stage and help translate ideas into manufacturable products. And finally, we covered the tools used in technical drawing, from traditional manual tools like T-squares and French curves, to modern CAD software like SolidWorks, AutoCAD, and Fusion 360. These tools not only make your drawings more precise but also allow you to simulate, revise, and share your designs more effectively in today's fast-paced industry. So, whether you're sketching ideas by hand or modeling a complex product in 3D, technical drawing is a skill that bridges creativity and engineering, helping you turn ideas into real, functional products. Thank you.